Hello. For the lab exercise, I thought that before I assign spectroscopy problems to you, that I would work through some example problems. Okay, in this first example, we have C5H10O. Okay, the fully saturated would be C5H12. So we're missing two hydrogens. We've got one unsaturation unit. Okay, here it is, 1716. That's a carbonyl. And there is nothing to indicate an aldehyde. The aldehyde would be down here around 9 to 11. So it's most likely a ketone. Okay, in the proton NMR, we look at mainly three things, and that is the chemical shift, the position along the x-axis, which tells us about the chemical environment. And so these peaks here between 2 and 2.5 would be hydrogens on carbons next to the carbonyl, in other words, alpha hydrogens. Okay, so we have a CH3 next to the carbonyl. Okay, the other thing that proton NMR tells us is the number of hydrogens producing that signal. So this is a CH3, and this tells us there's no hydrogens on the neighboring carbon. So this would be the CH3 next to the carbonyl. Okay, on the other side of the carbonyl, we have a CH2. Okay, and I know that because of the integral. And then this is a triplet, so that tells us there's a CH2 next to it. Okay, then we have, so we've got CH3, carbonyl, CH2, another CH2, and a CH3. All right, so this looks like so this looks like two pentanone or pentan-2-one. Okay, CH3 next to the carbonyl, CH2 on the other side of the carbonyl. It's a triplet because there's two neighboring hydrogens. This is a multiplet because it's split by these two and these three. This is a triplet because it's split by these two. Okay, this is another ketone. That's 2-heptanone. I won't go through that. Okay, here we know this is an alcohol. I'm going to go on to the next. This one happens to be isobutyl alcohol. We'll go on to the next one, which is another alcohol. All right, so we have C6H14O, no unsaturation units. Okay, we have an alcohol, and all right, so this is probably the alcohol peak, the OH right here, and down around 3.5 to 4, this would be one hydrogen on a carbon next to the oxygen. Okay, so if we do this, okay, there's one hydrogen here, and it's a multiplet, so it's split more than once, split several times. Then we have 6 hydrogens. That's probably 2 methyls. Okay, and that's at the far end. Okay, so we got 1, 2, 3, 4, 5. Okay, let's make that a methyl. Okay, so 1, 2, 3, 4, 5, 6. Okay. So if we look at it, this is the CH on the carbon with the OH on it. Okay, we got our two methyls. This is the methyl on the other side of the CHOH. And then we have one hydrogen buried in here. And then there's a note here. Methylene protons adjacent to chiral centers may not be equivalent. Okay, so we go back to our drawing. Okay, we've got a CH2 right here, and these two hydrogens are actually not equivalent because they are next to this chiral center right here. And so they're what we call diastereotropic protons. Okay, so this is one of our CHs, CH, CH, and then CH. Okay, so this is 4-methyl-2-pentanol. Okay, if we go on to the next one. Okay, this is one that has, looks like 1 unit of unsaturation, C4H8O. We do have a carbonyl. Okay, and because the carbonyl absorption is a little higher than usual, okay, ketones are usually 1710, 1720. This is 1743. Okay, so that would imply that it might be an ester. Okay, and that's consistent here with the two oxygens. Okay, between 3.5 and 4, okay, that would indicate protons on a carbon next to an oxygen. So we have CH3 and then oxygen. And then we have our carbonyl. Then we have an ethyl group. Okay, so this would be okay, so we would have an oxygen here. And then we would have our carbonyl group here. Right, so this is a compound known as ethyl acetate. Okay, we have a triplet and a quartet, which would be an ethyl. Between 2 and 2.5, that would be alpha to the carbonyl. Okay, if I go back here. Okay, alpha to the carbonyl. Okay, next to an oxygen, remember these would be about 3.5 to 4. And then we have and this is a quartet because there are 3 adjacent, the n+1 rule. Then the methyl on the end is a triplet because there's 2 adjacent. Okay, so that would be ethyl acetate. Okay, this is likely to be another ester. Okay, again, we have 1 unit of unsaturation. The carbonyl absorption here is a little higher than usual, 1740, so that would imply that there's an ester. Okay, so we've got CH2, CH2, CH3, CH3. Okay, so this would be a CH2 next to the oxygen. Okay, so we would have and it is a quartet because there are two adjacent. I'm sorry, three adjacent. And then this is a triplet because there's two adjacent. Okay, so we've got 1, 2, 3, 4, 5. Okay, so that fits our molecular formula. Okay, so this is one that's called ethyl propanoate. Okay, going on to the next one. Okay, I'm going to, okay, this is another ester. We'll go on to the next example. Okay, this is a different functional group. Okay, so this is 1728. That would indicate a carbonyl. We have one unsaturation unit. And okay, we have our two stretches here, 20 at about 27 to 2800. Okay, that would imply an aldehyde. Okay, this region in here is our CH stretch. So we've got a carbonyl, and okay, this peak down here confirms that it is an aldehyde, and it shows up at about 9.7. Okay, so it looks like we have an aldehyde, CHO, and then we have CH2, 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 CH3. The CH2 that's showing up at about 2.4, that is the one that is next to the carbonyl carbon. Okay, so this would be pentanal. Okay, this one is, okay, this one's a little more complicated. Okay, here we have, okay, C11H24 would be the fully saturated, so we're missing 10 hydrogens. So that would be 5 unsaturation units. Okay, so we have 1693. Okay, that's a carbonyl, but it's conjugated. And then we have a peak down here at about 1600. Okay, that would possibly indicate a benzene ring. And okay, so we clearly have an aldehyde peak. And the aldehyde is, aldehyde would be attached directly to the benzene ring, okay, because the absorption frequency is lower, about 1693. Okay, so we have an aldehyde, then a benzene ring. Okay, these absorptions here between about 7 and 8. Okay, those would also indicate a benzene ring, and it would be a disubstituted benzene ring. Okay, so let's go back to our drawing. Okay, so we would have a benzene ring. and we would have an aldehyde. Okay, so this is the aldehyde hydrogen here, directly attached to the benzene ring. It's a disubstituted benzene ring. And if we look at the splitting pattern, it's a doublet and a doublet. The only way we could have a doublet and a doublet would be to have a para-disubstituted. Okay, this little peak right here, that's from the chloroform solvent. Okay, so this has to be a para-disubstituted. Okay, so we have another oxygen to account for. Okay, so we probably have an oxygen and then a CH2, 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 CH3. Okay, so we have a butyl ether group. Okay, so on the other side, okay, we have an oxygen and 2, 3, 4. Okay, so butyl ether group. Okay, if we go back to our structure, this is our methyl on the end. It's a triplet because there's a CH2 next to it. This would be the CH2 next to the oxygen. It is also a triplet. It's also a triplet. Okay, because there's 2 adjacent. Okay, the only way that we could have this doublet would be to have a para-disubstituted. Okay, let's look at this. Okay, if we had a ortho or meta-disubstituted, we would have a more complex splitting pattern. Okay, so these 2 hydrogens here are equivalent, and they're split by these hydrogens here. Okay, the ones that are farther downfield, that is, the ones that have a higher chemical shift, are the ones closest to the aldehyde. The ones that are more upfield would be closer to the ether. Okay, so that would be 4-butoxy-benzaldehyde. Okay, this is clearly a carboxylic acid. Okay, here is the carbonyl. Okay, we have 1 unsaturation unit. We have a very broad OH. Okay, instead of the OH being here, like we would have for an alcohol, it's very broad. In fact, it's right on top of the CH. Okay, there's only one possible carboxylic acid with that formula. That would be what we call propanoic. Okay, CH3CH2COOH. Okay, here is our carboxylic acid proton. Okay, sometimes these are broad, and it's way downfield, around between 11 and 12. And then we have an ethyl group next to the carbonyl. All right, so this is another carboxylic acid. Okay, I'm going to move on to the next one. Okay, C7H9N. Okay, if we subtract the nitrogen, one of the hydrogens, that would be C7H8. The fully saturated compound would be C7H16. Okay, so we're missing 8 hydrogens, so that's 4 unsaturation units. Okay, so this would indicate an NH2. Okay, broad, but not as broad as a alcohol. It's in the same place. Okay, and because we have two peaks here, that would indicate an NH2. Okay, it looks like we have a benzene ring. Okay, around 7 to 8. Okay, so benzene ring. Okay, the ring is 1 unsaturation unit, and then we have 3 for the double bonds. So that takes care of all of our unsaturation units. Okay, this broad signal right here, that would be our NH2. Okay, and so looks like we have a benzene ring, which would take care of 6 of the carbons, and then we have a CH3, which would take care of the 7th. Okay, so it looks like we have a benzene ring with a CH3 and a NH2 on it. So this would be a methyl aniline. Okay, well, it's not 4-methyl aniline because we would have a nice clean doublet. Okay, so what it looks like we have is probably 2-methyl aniline. Okay, we've got this triplet out here, 2 adjacent. We've got another triplet, and it looks like we have a doublet here. Okay, C5H13N. We subtract the nitrogen and 1 hydrogen. Okay, that would be no unsaturation units. And again, it looks like we have an NH2, have a primary amine. And okay, here is our NH2. Okay, we have 5 carbons. Okay, and there's actually not that many isomers of this formula. Okay, we can rule out several of them. Okay, if we consider this skeleton, and this skeleton, neopentane, whoops. Okay, if we had our NH2 here, okay, we would just have a singlet for these. Okay, that's definitely not what we have. And not only that, but this is probably the H on the carbon next to the nitrogen. And there's only 1 hydrogen there. And it's split into several lines. Okay, so we've got a CH, we've got a CH2, a CH2, and 2 CH3s. Okay, so if we go back, Okay, our NH2, okay, can't be on the end because we said that there's only one hydrogen on the carbon next to the nitrogen. It wouldn't make sense to have it here because we would have two equivalent ethyl groups, and that's not what we have. Okay, so it could be 2-pentanamine. Let's see if that makes sense. Okay, yeah, that looks like it would make sense. 2-pentanamine. We've got our CH2, CH2, and then we've got two CH3s. Okay, there's one here and one here. Okay, so 2-pentanamine. If we had our NH2 here, okay, that there's no way we could have our CH2, our two CH2s. Okay, so here we have our two CH3s. Also, we would have three CH3s, which is not what we have. Okay, this would be an ether. I'm going to go on to the next example problem. Okay, this is a small molecule, C4H9Br. There's only 4 possible isomers. There would be N-butyl, isobutyl, sec-butyl, and tert-butyl. And okay, it's not tert-butyl because we would only have a singlet of 9 hydrogens, which is not what we have. Okay, so this is being around 4. This would be the hydrogen on the carbon that also has the bromine on it. Okay, so what we have is a CHBr, and we have a CH2, CH3, CH3. Okay, so the only one that would make sense would be 2-bromobutane or sec-butyl bromide. Okay, we've got a straight 4-carbon chain with bromine on number 2. Okay, and then this is split by, this is actually split by the methyl, and then it is split by the CH2 on the other side. Okay, so this is the CH3 on carbon number 1. It's split into 2 by the 1 hydrogen on carbon number 2. Okay, so that would be 2-bromobutane. Okay, this is an alcohol. Okay, and 1599. Okay, that would indicate a benzene ring. C10H22 would be the fully saturated. And so we're missing 8 hydrogens, so that's 4 unsaturation units. So we have a benzene ring. And this also indicates a benzene ring. Okay, peaks around 7 to 8. Okay, and it would be a para-disubstituted, 1,4-disubstituted, to have this doublet pattern. And So we have 9 equivalent hydrogens. Okay, that's probably a tert-butyl group. Okay, so there's 4 carbons in a tert-butyl group, 6 in a benzene ring. Okay, so I would say this is 4-tert-butyl phenol. Okay, this is the OH. It's a disubstitute of benzene, and then we have a tert-butyl at the 4 position. Okay. Let's go on to the next one. I'm going to skip this one also.